So we will see the next storage class, that is external storage class. First we will explain what is external storage class with the help of an example, and then we will move on to the slides. So the examples we are going to write, or examples we are going to use for explaining storage classes, are all simply for the purpose of explaining them. They don't do particularly anything. They are just for the explain of this storage classes. So the application of these programs are nothing. We are just explaining what is a storage class. Okay, so let's start by writing a simple program. I have named the file as external.c, and I'm declaring a variable a, and I'm initializing it to 10. I'm printing the value as a equal to %d/n a. I'm using a function called void fun a. Here also I'm declaring a variable a, and I'm initializing it to 12, or let's say here I'm declaring a variable b, and I'm initializing it to 12, and then I'm printing the value of b. Okay, and then to make this function work, we have to call the function fun a, and we have to put the function declaration at the top with the semicolon. Okay, so this is a simple program. Can you say what will be the output of this program? The output will be a equal to 10 and b equal to 12. Let's see that. gcc hyphen o external.c, and when you run this program, a equal to 10, b equal to 12. That's what we are getting. So if I ask you what is the storage class of a and b, both are having a storage class of automatic because they are declared inside a function. Now let's try one more thing. We can declare a variable outside all the functions. Say I can declare a variable c here, and I am going to put the value 20 here. So this is a major difference. Till now we have not declared any variable outside the function main or outside any other function. So note the point of this declaration. This is declared outside all the functions. So what is the use of this, or what is the benefit we are getting when you declare a variable outside all the function? First thing is, any variable declared outside all the function will have a storage class external. So what is the purpose, or what is the use of this? If you declare a variable outside all the function, it can be accessed by all the other functions in the program. So for example, I can say printf c is equal to %d c. Here also I can put c. In the previous example, if you write something like this, it will throw an error because c is undeclared in the function, because c is not declared inside main. Here also c is not declared inside the function fun a. But in this case it won't throw any error because c is declared outside all the function. Hence the storage class of c is external. It is accessible to all the functions in the program. So if I ask you what is the scope of this variable c, you have to say it is the entire program. All the functions in the program will have access to the external variable. So the scope of external variable is entire program. And what will be the lifetime of the external variable? It will be till the program lasts, not till the function lasts, but for the entire lifetime of the program, the value inside the external variable will be remembered by the variable. So the lifetime is till the program lasts. And about initial value, here I'm putting a 20 inside C, so it will have a value 20. But if I'm not putting any value inside 20, by default all the external variables will have an initial value of 0. In the case of automatic variable, the initial value was a garbage value if you don't put any value inside that variable. But in case of an external storage class, it will be 0. So the 3 points: the scope is entire program, lifetime is till the program lasts, and finally initial value is 0 if you don't put any value inside it. Let's try running this program now. Compile the program, run the program. You can see A equal to 10, C equal to 20, B equal to 12, C equal to 20. So C is accessible. Now let's make a change here. I'm incrementing C by 1. What will be the change in the program? Here I am incrementing the value of C, which is an external variable. External means it is visible to all the functions. So if I change the value of C in main, the change will be visible to the function A also. So what will be the output here? Let's try recompiling the program and running the program again. Now if you notice here, A equal to 10, C equal to 20, plus 20 here. Now I am incrementing C by 1 and then calling function A. Here I am printing B and C. So that incremented value is displayed here, 21. So any changes you make to the external variable in a function will be visible to all the other functions in the program. So that is the use of an external variable. So if you want to make a variable visible or accessible to all the functions in the program, you have to declare it as an external variable. So what did you do to make a variable external? Did you use any keywords? No, you just have to put the variable declaration outside all the functions. What did you do to make a variable automatic? You have to declare a variable inside a particular function. Okay, so that's it about external variable. Now we will move on to the slides explaining this. So variables that are both alive and active throughout the entire program are known as external variable. They are also known as global variables. So this is what I mentioned. The lifetime of an external variable will be till the program lasts. So that's what it is meant by alive and active throughout the entire program. Unlike local variable or automatic variable, global variables can be accessed by any function in the program. That also we have seen. Global variables will be initialized to 0 if not initialized explicitly. That also I have mentioned already. If you don't put any value inside a global variable, the variable will have a value 0. And the external variables are declared outside all the functions. That is also explained in the previous example. So here is another simple example. In this sample program, we have 3 functions: main, function 1, function 2. And I am declaring 2 variables, number and length. Both of them are declared outside all the functions. So the storage class of the number and the length variables are external because they are declared outside all the functions. So all these functions can use these variables. And the next point, Changes made to an external variable by one function will be visible to all the functions in the program. That we have seen in the example. If I change the value of the external variable c in the function main, then that change will be visible to the other function a. Suppose there are two variables, both have the same name, that is a local variable and a global variable. Both of them have the same name. Then local variable will have precedence over the global variable in the function where it is declared. So if there is a conflict between a local and global, then the local will be preferred over the global. So what is meant by that? Let's make a change to our example. Suppose this function a has a variable declared c inside it. Now if you see that this function a has two c's visible. One is this global c, another is this, initialize it to some 15. Okay. Another one is declared inside c. So this is what is meant by the conflict here. So in case of a local variable and global variable has the same name. So here this local variable has the name c and this is a global variable with the same name c. So what will be the value printed here if I print the value of c? You have two options here. Either it will be 20 or 21 after the change, or it will be 15. So according to this point, the local variable will have precedence over the global variable. So let's try out. I'm going to compile this program, run the program. Now if you see this thing, c is now printing 15 instead of 21. So that's what is mentioned here. When you have both local and global variable having same name, the local will get precedence. Precedence means priority over the other one. Okay, so this is a simple program explaining that suppose there are three functions, fun1, fun2, fun3, and this is a global variable x, and in the main function I'm not declaring anything. X is equal to 10. So any error in this one? No error, because x has been declared as a global variable, so you can use this. So this is a global x. What does this mean? This is a comment. Then I'm printing x is equal to percentage d. What will be printed? This 10 will be printed here. Now again I'm printing x is equal to percentage d after the function fun1. I'm calling the function fun1, so the program will jump to this function and I'm incrementing x is equal to x plus 10. What will be the change? This global value, initially in the main I have put it as 10, that will be incremented by 20. That change will be visible to the main function. So here x is equal to 20 will be printed, and in the next line again we are printing x is equal to percentage d and calling the function fun2. So here the fun2 will be called, but here there is a problem. There is another variable x with the same name declared locally inside the function fun2, and I am returning that value, return x. So what will be printed here? It will not be 20 because it is the local value of this one. X equal to 1 will be printed. So x is equal to 1 will be printed here. Finally again we are calling this x is equal to percentage d fun3. So program will jump into the function 3. Here x is equal to x plus 10. So the value of x will be now changed to 30, and that 30 will be reflected here. So the output of this program will be x is equal to 10 for the first printf, x is equal to 20 for the second printf, x is equal to 1 for the third printf, and x is equal to 30 for the final printf. So this is how external variables work. And one final point to be noted is, if an external variable is declared after a function, then the variable must be declared inside the function using the storage class specifier extern. So this is what is meant by that. Here there are two functions, main and fun1, and this I is a variable which is declared outside all the function, but there is a difference with the examples we have seen. In all those examples we have declared the external variable above the main function or above all the functions. But here we are declaring it after all the functions. So if you are declaring an external variable after all functions, then you have to put this line explicitly. That is, the keyword extern is used here, extern int I. Note that this is not required when you put this int I above all the functions. But if you are putting it after all the functions, you have to use the keyword extern, otherwise it will throw an error. So that's it about external storage classes.